Hey guys, it's Katya, and today I will be helping you guys through the Chapter 6 Statistics Quiz B. So number 1 says that during a budget meeting, local school board members decide to review class size information to determine if budgets were correct. Summary statistics are shown in the table, and the table is this right here. It says, notice that the third quartile and the maximum class size are the same. Explain how this can be. Now, this can be the same because that would have to be that the top 25% of all classes have 40 students enrolled. Now for B, it's asking the school district declares the classes with enrollment fewer than 20 students are too small. Would you consider a class of 25 students to be unusually small? Explain. So as you can see on my answer key here, it says that yes, classes with 20 students enrolled seem unusually small. 20 is well below the first quartile of 29, which is right here, 29, which is quartile 1, and only slightly above the minimum size, which is 17, and that's seen right here, min 17. So right here, you're actually finding the z-score to find how many standard deviations away it is. So you're taking the number you're looking at, the number of students right here, which is the x-bar, and you're dividing that by the standard deviation, which is 5.66, and you get that it is negative 2.366. Now that gives you the z-score. So what that is saying is that this class size is over 2 standard deviations below the mean. Now, as you guys remember, standard deviations explain how far away it is from the mean, and the more that it is, or the bigger the number is, meaning the farther away it is from the mean, that is how it's considered to be more unusual. So this is question C, and it says the school district sets off the office supply budget of their high school on the enrollment of students. The district budget each class is $12 plus 75 cents per student. So a class with students receiving $12.75, a class with 1 student receives $12.75, and a class with 40 students receives 12 plus 75 cents times 40, which is $42. They would like to know the median class budget for office supplies and the interquartile range. So the way to find the median is by going 12 plus a 0.75 times 33, which will equal you out to 36.75 or $36.75. Now this right here is finding the median. And the way to find the quartile 1, which is the lower quartile, is 12 plus 0.75 times 29, which is 33.75. Now the reason why you're using 29 here is because that is the number up here for quartile 1, so that's why it gets plugged in here. And then to find the upper quartile, or quartile 3, it would be 12 plus 0.75 times 40. Alright guys, my apologies, I hadn't realized it turned off. So getting back to what we were at, it is 12 plus 0.75 times 40, which equals $42, and that right there is for quartile 3, and the reason why you have the 40 that's here is because of your Q3 being 40. So the last thing they're asking you to find is the interquartile range, which will just be Q3 minus Q1. So what that will be is 42 minus 33.75, which will give you 825. So that should be what you get for your interquartile range right here. And that right there completes question C. Now in part D, we're being asked what the mean and standard deviation of the class office supply budget is. So for the mean, we will write down, I'm going to bring this off to the side just a little bit so you guys can see what I'm writing. For the mean, it'll be 12 plus 0.75 times 33.39. Now the reason why you're going to use that 33.39 is because, again, up here, x bar is 33.39 students. So you're going to go 33.39, and that will give you 37.04. So that right there is your mean, and the standard deviation will be 0.75 times 5.66, which equals 4.25, or $4.25. Now, the reason you guys are going to use that 5.66 is because, again, up here, that right there is the standard deviation right here. And you're plugging it into the 75 cents that you will get per student. And that right there completes question. So for question 2, because I wanted you guys to have a clear picture of what's going on, I'm going to use my answer key. So the question says that the postmaster of city post offices believes that a normal model is useful in projecting the number of letters which will be mailed during the day. They use the mean of 20,000 letters and a standard deviation of 250 letters. Now, the question was to draw a clearly labeled model, and your paper should look blank like this, but this is what you should have drawn. So you're going to start off with your mean being in the center, and that is the 20,000. And for each standard deviation, because it clearly states up here that it's 250, you will add on 250 for each one of these going up a standard deviation and subtract 250 for each one going down a standard deviation. Now this right here is one standard deviation, which is the 68. This right here is 2 standard deviations, that's why it's 95. And this right here is the 99.7%, which is 3 standard deviations, and this follows again the 68, 95, and 99.7 rule. And that right there completes question 2. Now number 3 is a question about light bulbs. It says a standard white light bulb has a mean life of 375 hours and a standard deviation of 50. And a soft white light bulb has a mean life of 700 hours and a standard deviation of 35 hours. At a local science competition, both light bulbs lasted 750 hours. Which light bulb's lifespan was better? And explain. So this right here is the standard, and that would be Z equals 750 minus 675 divided by 50, which equals 1.5. Now this is using just the basic Z formula, the Z-score formula. And for the soft lights, we have Z equals, 750 minus 700 divided by 35, which equals 1.42. 4286. So this right here is your 2 basic Z-scores. Now, my paper gives an explanation as to why for the second part of this question, which is to explain, and that is that standard light bulbs last more than 1.5 standard deviations above the mean life, compared to the soft light bulbs at 1.4286 standard deviations above the mean. The standard light bulb performance was slightly better. As you can see, that is the difference between the 1.5 here and the 1.4286. Question 4 states that at a large business, employees must report to work at 7:30 a.m. The arrival time of employees must be described by a normal model with mean of 7:22 a.m. and a standard deviation of 4 minutes. Now, 4 is asking what percent of employees are late on a typical work day. So I'm going to pull over to my answer sheet. So for this one right here, it says employees are late if they arrive at after 7:30 a.m. So you're going to start off by finding your Z-score, which starts off with it being the mean of 22. So you take the arrival time of 30 minus the mean time, which is 7:22, and dividing that by the standard deviation, which equals 2. So the Z-score, you're going to find the probability of that. So you're going to plug this into your calculator, and it gets you 0.0228. So it says, according to a normal model, about 2.28% of all employees are expected to arrive after 7:30. And this right here is just a nice graph of a normal model to help you understand what's going on here. So this is your mean, and this is their arrival time of when they're considered late. So this is their on time, and after this, they're late. And this right here is the percent of people who will be arriving late. All right, B is asking, a psychological study determines that the typical worker needs 5 minutes to adjust to their surroundings before beginning their duties. What percent of business employees arrive early enough to make that adjustment? So again, you're going to be using the Z-score formula, which is just 25 minus 22 divided by 4, because we are still using the mean and standard deviation from up here. So when you do that, you will get 0.75, and when you find the probability of that z-score, it'll give you 0.773. So according to the normal model, about 77.3% of employees will arrive at work before 7:25. So right here, again, this is just a nice graph to help you understand. This is a normal curve where your mean is at and where they need to be arriving at so that they can get their 5 minutes in. And this right here is how many of them will arrive before 7:25 to get their 5 minutes in that they need. So number C says that because late employees are a distraction and cost company money, all employees need to be on time to work. If the mean arrival time of employees does not change, what standard deviation would the arrival time need to be to ensure all employees are on time to work? So the answer is that virtually all times lie within 3 standard deviations of the mean, except other reasonable z-scores greater than 3. So if the z-score is less than or equal to 30 minus 22 divided by the standard deviation, then 3 standard deviations is less than or equal to 8. So the standard deviation should be 2.67 minutes. And for D, it says to explain what achieving a smaller standard deviation means in the context of this problem. And a smaller standard deviation would mean greater consistency in arrival times. And that is the end of Quiz B.